All right, so P8, we're going to get into modeling with equations. So we're going to get into like real world examples and how to solve those. So working with word problems. But before we do that, kick off here. So always got to keep in mind, so you need to make sure this is factored out first. X plus 1, x minus 1 is. However, this will go to x minus 1, x plus 1, being a difference of squares. So we always have to think about those exclusions, what x cannot be, which would be 1 and negative 1. So if we go through and we times by the common denominator, which is going to be x plus 1, x minus 1, because that's all the factors that we have involved here. So this first one, you would lose the x plus 1, so you would need an x minus 1 on top. Here, both of those would be gone. And then lastly, x minus 1's cancel, so you would take it times x plus 1. So if you think about 2, we're getting rid of these denominators here, because it's just simplifying it down. But what would this one here need? Well, this one would need the x minus 1, so that's what we're times it by the top. This one here would need the x plus 1. This one wouldn't need anything. So if you think after we do that, the denominators are gone, and then we can just solve. So 1 times that would be x minus 1. So right side we'd have 2 minus 1 times our x plus 1 would be x minus 1, because this minus has to get distributed to both. All right. So if we have a minus 1 on both sides, those are going to cancel. Then we can add our x over. So 2x would equal 2. And when we divide by 2, x would equal 1. Now, our solution is 1, but yet we said x couldn't be 1 or negative 1. So that makes it no solution. Because even though that's what it has to be, it can't be that based off of our restrictions to our domain. All right. So when it comes to word problems, first thing you want to do is read through the entire problem carefully. And then you want to start pulling information from it. So what information did they give you? What information do we need to find? We're going to try to state that problem in our own words. So, okay, we need to add these up and set it equal to the total. Or we need to set this up and divide it to get down to what we need to be. You know, we're going to try to state what we're looking for, and we're going to use x, or really any variable, but we're going to use one variable then to represent what we don't know in the problem. Now, if there's multiple things that we don't know, we're still going to try to write them in terms of that variable, which typically is going to be x here. We want them all in that one variable, because the more variables we have, the more equations we're going to need to have in order to solve those down, and that turns into a system of equations. But once we have those variables, then we're going to write that equation in terms of x there, or whatever variable we pick, and it's going to model those conditions of the problem. Then we're going to solve it, and then make sure we answer the question, and always kind of go back and think about checking, you know, does that answer make sense? So the number of steps it takes to burn off a cheeseburger exceeds the number needed to burn off a 12-ounce soda by 4,140. The number needed to burn off a donut exceeds the number needed to burn off a 12-ounce soda by 2,300. And if you chow down on a cheeseburger, donut, and a 12-ounce soda, a 16,790 step walk is needed to burn off those calories. Determine the number of steps it takes to burn off a cheeseburger, a donut, and a soda. So when we start this off, both of these are referring back to the soda as our, we need this many more steps than what the soda is. So we're going to let the soda be x. So that makes our cheeseburger be x plus, we're exceeding it by 4,140. So 4,140 plus our x there. And then lastly, our donut would be that x, because again, we're tying it back to that soda, but it's going to be 2,300 more, so plus 2,300. Well, we know our total is 16,790, so we're going to add them all together, set it equal to that total. So x plus our 4,440, and then plus our last one of x plus 2,300. Which equal our total of 16,790. So put like terms together. X, X, and X. We have three X's. 4,140 and 2,300 is going to go to plus 6,440. Still equal to our 16,790. So subtract that 6,440 over. 3x would then be equal to 10,350. And if we divide by 3, x would end up being, and I'm off the screen, sorry, 3,450 for our steps. So if we go back up here, so does just the x. So it's going to be the 3,450 steps. Cheeseburger was at 3,450 plus 4,140. So it's going to end up being 7,590 steps. And lastly, the donut. We take that 3,450, add the 2,300, and I have 5,750 for our steps. So, one yardstick for measuring how steadily athletic performance has improved is the 1 mile run. So, in 1923, the record for the mile was a comparative sleepily 4 minutes, 10.4 seconds. And in 1954, I don't know how sleepy that is, but that's what it said in the book. In 1954, Roger Bannister of Britain cracked the 4-minute mark, coming at 3 minutes, 59.4 seconds. In the half century since, about 0.3 seconds per year has been shaved off of Bannister's record. If this trend continues, by which year will someone run a 3-minute mile? Well, we're going to know how long until 3-minute mile. We're at 3 minutes, 59.4 seconds in 1954. So how much time do we have to drop? Well, we're dropping 59.4 seconds. We want to know how long it's going to take to drop that. So if we're doing 0.3 per year, we're going to do 0.3x, x being the years. So x equal years. Okay. So from there, really all we have to do is divide by 0.3. And so x is going to be in 198 years. Now, did we answer the question? Well, no, because it wants to know what year is it, not how many years after. So if we take, I'm getting ahead of myself, 1954 plus our 198, that's going to end up being the year 2152. So that's going to be the year it's going to happen. Okay. Now, in 2002, the median annual income for people with a college degree was $52,000. This is a 160% increase over the median income in 1982. What were people earning with a college degree in 1982? We're going to let X be the 1982 income. So we know in 1982 we made X. Well, in 2002 we're going to make that and then an increase of 160%. So that increase of 160% is going to be an additional amount. So we're going to add 1.6x being 160% as a decimal times our X, which was the median income in 1982, equaling our 52,000. So we know in 2002 it was whatever it was in 1982 plus another 1.6%, or 160% or 1.6 of that amount. So put your like terms together. X and 1.6 makes 2.6x, equaling 52,000. Divide by 2.6. So X is going to end up being 20,000, and we're in dollars. All right. So, have some different geometric shapes here. If you notice above, we have area, perimeter, or circumference if it's a circle of these different ones. Now, notice how these don't have a perimeter. Both of these You just add up the sides on these two shapes. The other side of this, we have 3D shapes that you can do volume with. So just providing all those different formulas so you can do equations like this. So the length of a football field is 200 feet more than the width. So that right there, L is going to be 200 plus RW. So if the perimeter of the football field is 1,040 feet, what are the dimensions? Well, if we look at a football field is a rectangle. Perimeter of a rectangle is that P equals 2L plus 2W. Well, if we know the length is 200 plus more than W, we can sub that in for L. We also know our perimeter. We'll be able to solve our W. So perimeter is 1,040 feet. We'd have 2 times our L, which is 200 plus W, plus our 2W yet. Distribute the 2 in. So 1,040 equaling 400 plus 2W plus that last 2W. Well, now we have like terms. We can put the W's together. So 1,040 equaling 400 plus 4W. Now we can solve it like any other equation. Subtract the 400 over. So we'd have 640 equaling 4W. And dividing by 4, W would end up being 160, and we're in feet. So as far as length goes then, we know we're 200 plus whatever that W was. So 160 plus 200 is 360 feet. All right. So Pythagorean theorem, a squared plus b squared equals c squared. This is the one over by the wall by my air conditioner, if you ever can't remember this. But now I also want to point out I did not make up this problem. It was in the book, but we're going to do it anyway. So wheelchair ramp with a length of 122 inches has a horizontal distance of 120 inches. What is the ramp's vertical distance? Well, if we draw out a ramp here, we're going to make this with the right triangle. So the ramp is 122. Our horizontal is 120. And that vertical side is what we're looking for. So we're going to have 120 squared plus b squared equals 122 squared. So these two sides, your legs that touch the 90 are your A and your B. Opposite side, your hypotenuse is your C. That's how I'm filling it in. So if we square the 120, we're going to get 14,400, still plus b squared, equaling 122 squared is 14,884. So subtract your 14,400. B squared is going to end up equaling 484. And when you square root that, B ends up being 22 inches. So that's going to be our vertical distance here. All right. Now, construction laws are very specific when it comes to access ramps. Every vertical rise of 1 inch requires a run of 12 inches. So for every foot of run, so every horizontal distance of a foot, it has to go up 1 inch. Will this satisfy those requirements? Well, right now, so this was part A up here. So this is part B. We're 120 inches of run. So that 120 inches, if we divide it by 12, that'll get us to be what it needs to be, which 120 divided by 12 is 10. So that's all the higher it would be able to go. Sorry, I did not realize that was the screen. So ours being 22 inches, we're way high. In fact, give you some perspective, whatever you want to say, visual with this. So when I went to college at Northeast, there was actually a ramp that I went on that was way too high than what it should have been. So I don't know if it was quite this high, but on that one, I almost flipped over backwards trying to go up it. And so I couldn't go up it. And so they actually had to go through and redo it all. But for that 10 foot of run of that ramp, that's all the higher this could go. So I think for this to be legal, it would have to stretch out to 22 feet long to get that much of a rise. And lastly, so we have a group of friends that are going to equally share the cost of a $50,000 yacht. Before the purchase is made, one more person joins the group and enters into this agreement. As a result, each person's share is reduced by $2,500. How many people were in the original group? So, this is how we're going to set this up. If you think about what the share is to begin with, it would be the 50,000 divided by the X amount of people. We're going to let X be original people. So each person's share would be that total amount divided by the however many people are there. Now, we know the share changes by 2,500, so we'd subtract 2,500 from that, and that's going to give us our new shares. So it's still the 50,000, only now we're not just dividing by X, we had one more person join, so we're going to be dividing by X plus 1. So if you think about it, this is original shares. This is share difference. And this is new shares. Is how I set that up. So if you think about it, our common denominator here is going to be X times X plus 1. So what does this one here need? Well, it's going to need an X plus 1. This one's going to need all of that. And this one here is only going to need an X. And that'll get rid of our denominators. So denominators are gone. So if we distribute the 50,000 in, we'd have 50,000 X plus 50,000. Here, we distribute the X in first to make this X squared times 2,500, so minus 2,500 X squared. X times 1 times 2,500 would be minus 2,500 X, equaling, on the other side, 50,000 X. Because that's all we'd have to times by there. So if you notice, we both have 50,000 on either side. So that alone is going to cancel out. And if I rewrite this as minus 2,500 X squared minus 2,500 X plus 50,000 equals 0. Now we have a quadratic equation here. Something that we've solved many times. So the first thing we always do is we look for, do we have a common factor? Well, we do. We can pull 2,500 out of each of these. And we're going to pull a negative 2,500 out. So we'd be left with, this would just be a positive X squared. This would just be a plus X. And there's going to be 20. So minus 20, then for the last one equaling 0. So if you take 50,000 divided by 2,500, you're going to get 20. And by pulling that negative out, that makes it a lot easier to work with. Now, if we divide this over, it would be gone. So because it's just a number and no X, it really isn't going to factor into anything. So what we can do now is two sets of parentheses, still equal to 0. So X and X, it being a minus, one is a plus, one is a minus on our factors. And so we're looking at factors of 20 that when we subtract, we get 1. Well, 5 and 4. We put the 5 with the 1 because our middle term is positive, so the bigger number needs to be positive. So if we go through and set each of these equal to 0, we would get X equals negative 5 and X equals 4. Now, can we have a negative amount of people? Nope. So that's not the answer. Our answer is going to be 4 people is what we had originally. So that's that lesson. Let me know if you have any questions. Until next time, we'll talk to you later.